recorded. Yeah, so I'm planning to talk about a few exercises on homework 4. So for the first exercise on 1 and 2, I think it's really relatively straightforward. So I will mostly talking about a few that might be computational intensive, and maybe some of the things that I wrote maybe will give you some hints on how to proceed. So I will probably start with exercise 3, which I think is a little bit computationally intensive. So maybe we can walk through or talk about it or think about it together. Is that okay for everyone? Yeah, so exercise 3 is that this 403, follow a, yeah, so suppose we have a vector, so which is a two-dimensional vector, y1 and y2, and also follow a bivariate normal, show that the conditional PDF of y2 given y1, and then also conditional on a particular observation, lowercase y1, follow a uniform, univariate normal distribution with this particular mean and the variance. Okay, so now we are going to set up the PDF here. So we are interested is the PDF of y2 conditional on y1. And we are going to use the definition for the conditional, which is the joint over the marginal. So y1 joint of y2, and then conditional on the one, so divided by the marginal of the random variable that we conditional on. So in this case, it's going to be y1. Maybe let me make it consistent. Based on your preference, you can use P or F for the PDF, but here I'm just going to use F. So this is more of a definition. Joint over the marginal will give you the conditional. Yeah. And then for the rest, it just plug in the formula and then grouping things. And what I mean is that we first need to write down the joint in terms of a scalar form. So we have a 2 pi and sigma 1 multiplied by sigma 2, and then 1 minus rho squared. Square root of that. And this serves as our normalizing constant. And then we have our exponent, which is a very long expression. Negative 1 over 2. And then we are, so because this is a very long expression, so it really depends on how you want to write it down or how you want to group things. So this is just one way to group or to simplify the terms. So I'm going to write the correlation, the terms involving correlation to the denominator, also associated with the negative 1/2. And then for the remaining terms, we can write it in the following way. So maybe I will use a square curly bracket for this. And then maybe you can use a square bracket for this. And then you can use like a parenthesis for the remaining terms, which will be like this. So y1 minus mu1 over sigma 1. And then together, taking the square. And then we also have the y2 minus mu2 sigma 2, and then taking the square. And then maybe I'll just write minus and then continue on the second line. So 2 rho multiply by y1 minus mu1 over sigma 1. Then multiply by y2 minus mu2 sigma 2. Yeah. Closing the square bracket and then closing the curly bracket. Yeah. So it really depends on how you want to write down the terms. Because this is very long expression. You can group things or having lots of terms, you can, for example, you can multiply the shared terms into each of the terms. So it really depends on how you want to write it. Yeah. So there could also be different ways to simplify the formula. But this is just the ways that we are going to write. We are going to use. Okay. So this is just like copy down from your handout of a joint bivariate normal distribution. And don't forget, this is the numerator, and we also have the denominator. So a long division, and then 1 over sigma 1, 2 pi, square root of that, and exp. Maybe also, just to align the notation, we have a curly bracket, and then 1 over 2. Y1 minus mu1 over sigma 1, taking the square. Okay, yeah, so our goal here is that we want to simplify this long division so that it will result in a conditional distribution that having this particular form of this mean and the variance. So lots of things starting from here will be by construction and by design. So for example, here we're going to multiply by 1. And this 1 is not going to change the quantity here, but it will help to ease the computation in the following. And we're going to write it as 1 minus rho over 1 minus rho and square. So yeah, lots of things here is going to be by construction or by design. Okay, so any question or comments up to this point? So this is what we are interested, the conditional. And then we're going to use the definition for the joint over the marginal. So always divided by the terms that we conditional on. And here we just plug in from your lecture notes or from Wikipedia the formulation for the bivariate and the marginal normal distribution. Yeah. And then the rest is just grouping the terms and then simplify and then see if we can match the mean that having this form here and the variance having this form here. So that will be our strategy. Okay. Yeah. So next we are going to group things simplify in the following way. So yeah, so here let's maybe first simplify this the two normalizing constant or the ratio of the two normalizing constant. So we're going to simplify these two terms, resulting in one fraction. So we only have sigma 2 and 2 pi square root. And also we have one more copy of 1 minus rho square. Okay. And next, we are going to work on the ratio of the two exponents here. So the division of two exponent is equal to the difference inside the exponent. So we're going to basically minus the exponent in the denominator here, and then resulting in the following. So exp, and then negative 1 over 2, and then 1 minus rho square. So we're going to borrow one copy of 1 minus rho square that we introduce by construction from here. Okay. And then the rest will, yeah, basically these are just, you can just copy paste from the above. But I need to, yeah. Okay, and what else? minus 2 multiplied by rho, sigma 1, and then y2 mu 2 sigma 2. Okay, and then here we just need to take care of the exponent in the denominator. So we bring the negative sign outside. So in here, we should also have a negative sign. This is just to compensate that here is the division. So you need to minus whatever inside this curly bracket. So you should have a minus sign here to compensate the minus sign here. That means we should have something like this. y1 minus mu 1 over sigma 1. So this is from the denominator. And don't forget, we also have one more copy of 1 minus rho. So here, 1 minus rho squared. Okay, so from the previous line to the second line, we just simplify the ratio of this normalizing constant and then grouping these together. Okay, so pretty laborious or maybe tedious here. And next, yeah, so I think here we can just analyzing or further grouping whatever is inside here, the exponent here. And let's see. Yeah, we can write it as 1 over 2. And then I don't want to talk through. I'm just going to copy paste other things here. I see. 1 minus rho square, and then I basically just copy again whatever I wrote here. Okay, but we introduce the 1 minus rho inside here. Okay, so what we want to show in here is that we have one copy of this. This will cancel out with another copy with 1 multiplied by that. So these two, the things that I put in the box, they should be canceled out. So that means on the last term, for the last term, we only have a plus rho squared multiplied by this thing here. Okay, and that should give us 1 over 2, and then y2 minus mu 2 over sigma 2. Yes?
Isn't there a negative on the 1 minus rho square when you bring it from the denominator to the numerator?
Which part? Sorry, can I say that again?
Steps back. Because there's already a negative in the denominator, you're doing a negative, right? So
you mean there's a negative here?
Go back where you had the joint and the marginal.
Here, yeah.
In the marginal, there's already a negative in the exponent. So when you bring it up, it becomes a positive, right?
Yes, but you still need to minus the 1 in the denominator, right? So here, maybe I can. So exp of A over exp of B, this is equal to exp A minus B, right? So you have another minus sign here.
That's what I'm saying, is that when you bring the negative exponent to the top, you're minusing a minus.
So you minus a minus, so that means you should have a plus, right?
Yeah.
So you have a minus sign here, and then that will make it plus.
Yeah. Is that correct?
Yeah.
Okay.
I mean, did I? Maybe I misunderstand your question. So you mean this minus should be a plus?
Yeah.
But I think this. So you have this minus that. So this should be this thing plus this the whole term here, right? And then I bring a negative 1/2 here, so I should change this back to minus sign,
Okay.
right?
Okay.
Does that? Yeah.
Another question, like on that last line that we see, there's an open like square bracket.
Which part? Which line?
Where you have 1 over minus 2 times 1 minus root squared. To the right of that, there's an open square bracket. Just, yeah.
Yes, perfect. Here, square bracket, right? Yeah. Is that what you mean?
Yeah.
Perfect. Thanks. Yep. Yeah. So yeah, here because we have a, for example, if we want to divide it by minus b, so, and then this will be a plus, but I bring a minus sign in the front, so it will be like that. So that will be the minus sign in the middle.
Okay.
Yeah, yeah. Yeah, and then there's yeah, and then also there should be closing a square bracket and then closing a curly bracket here. Yeah. Yeah. Any other question or comments? Because lots of I hope I'm not going to make you feel boring, but lots of things will be laborious or just grouping things. So yeah, you might feel very boring. Yeah. Okay, let's just, for completeness, maybe just bear with me. So yeah. Okay, and then plus. So yeah, so here, just coming back to here. So we have one copy in the front, and then we also have one copy here. 1 multiplied by that, and then plus rho squared multiplied by that. But here we just removed the one copy from the first term and the second term. So we only have a plus rho squared, and then y1 minus mu1 over sigma 1 squared. Yeah. So I think up to this point, you might recognize this as a plus b squared equal to 2ab plus b squared. So something like that. Yeah. So the rest is just how to distribute the terms and then to make it look like the things that we want. Okay. Let's see. Okay, so from this line to this line, we're just removing or canceling this one copy of this terms. And after we simplify to that, oh, okay, there's one more denominator. 1 minus rho squared. Okay. Next, we are going to multiply another 1 here. And then we are going to design this 1 as sigma 2 squared over sigma 2 squared. So basically just multiply by 1. So another thing is that is by construction here. And that should give us negative 1 over 2 y2 minus mu2 square sigma 2 over sigma 1 y1 minus mu1, y2 minus mu2. Okay, let's see, just to double check in case there's any typo. So I think if we multiply by a copy of a 1, so it should cancel out that. Ends up with one copy of that and one copy of sigma 1, and then square for that, and then another copy of that. Okay, yeah, so now it's just so now we can group them in the form of a plus b squared. So we can write it in the following. Yeah, so lots of this thing is going to be very tedious and laborious, and also really depends on how you want to group things. So there could not only this one way to write it, so you might have a different way to group things, and then that will give you the same result, but maybe different intermediate steps. Okay. So y2 minus mu2, so this should consider as a, and so that is a, and then we consider the whole thing here as b. Okay, that means we have a minus rho sigma 2 sigma 1 y1 minus mu 1. So a minus b. Okay, and the whole thing square. So this is just a minus b squared should be this thing here, and then the denominator stay the same. Yeah, so this is the things in the exponential term. And then we also have a ratio for a normalizing constant. So here just denote as a z, maybe subscript and c, normalizing constant. So what we have been working on is that things inside the exponential term. And then now we can just reading from this to recognize what is the new mean and the variance. So our new mean, we're going to denote it as, let's see, y2 conditional on y1. So our new mean for 2 conditional on 1 is going to be mu2 plus rho sigma 2 sigma 1 y1 minus mu1. So we just this thing here. So y2 minus the new mean. So here we change the sign here as a plus. And then for the variance, 2 conditional on 1. Sigma 2, 1 minus rho square root. Yeah, so this is the standard deviation, not the variance. And then it should be the same as in the homework. Yeah, any question or comments? Yeah, I just think this is a little bit computational intensive, so maybe this can help you to ease your burden on the homework. Yeah. Yeah, so I think the trick is just when we specify the joint over the marginal, we introduce a 1 minus rho square over 1 minus rho square. So that's the first thing by construction. And then another thing is that we need to multiply by sigma 2 over sigma 2 square, another construction to complete the form. And that should give us the new, the conditional mean and the variance. Yeah, any question or comments? Yeah, I wish I can just present or hand out the solution so that it's not going to make it too laborious. Yeah.
You can scroll up to the step before this one. Yeah.
Is here okay? Or
Yeah.
okay. Yeah.
Oh, okay. Yeah, so the right side where you have the sigma 2 squared, that's cancelling everything in the denominator within the A and B part on the left. That's how we're getting rid of the...
So your question is regarding this line, right?
Yeah, and so
Yeah.
that when you distribute it across, that's why all the denominators are... Yeah.
So we introduce this sigma 2 to cancel out all the sigma 2 on the numerator. So this should be canceled out, right?
Yeah.
And this should cancel out by having additional term here, right? And then we still have this term here. Yeah, and then everything else stay the same. And then by introducing another sigma 2 in the denominator, so we have an additional sigma 2 here. Oh, yeah, who was? Does that end?
So,
okay,
and,
good.
And as well,
Yeah.
could you maybe briefly comment on like how you would even think to do that? Because this is the kind of problem where it makes sense looking back or showing the solution, but if I were to get to that point in like on an exam, that's where I'll get stuck on my own, right? Unless you think of that exact construction. Can you comment on like maybe how you think of that?
So, yeah, the trick on how to design something like that and this actually just for tricks for exam or a homework, start from the solution that you want to show.
Okay, yeah.
That's the trick. Start from the solution.
Yeah.
So after you have the solution, and then think about what else is missing, and then bring it inside. Yep.
No, that makes a lot of sense.
Yep. No, that's the trick. Yeah. Always start from the solution.
Yeah.
Yep. Yeah. Okay. Let's see. Think exercise 4 is also straightforward, right? Basically just reading out the numbers that you need, extract the terms that you need, and then, yeah. So maybe if we have time, we can visit some of them. Yeah, I'm just planning to maybe write down something that is computationally intensive first, and then maybe I can comment a little bit on exercise 5. Yeah, so here we have, any other question before we proceed to exercise 5 for question 3? Okay, if not, then I'm going to talk about exercise 5. So we basically just have a n-dimensional multivariate normal, and then we're going to partition in the following way, in a 2x2 or in a 2 blocks, so that it will end up into this form. And so here we might not know the dimension for each of the component, by just that the total length is still going to be n dimension, but we're just going to partition into 2 blocks. So that's the bottom line. And also we have another another design that is we need a matrix A that multiplied by sigma 2 2. So this particular block is equal to the off diagonal blocks here. So that's the only kind of like a constraint here. And we going to let another matrix or another vector U define in this way, another vector V define in this way. And we are asked to find a joint for U and V. Yeah, so for this one, the trick is that we recognize part of the vector, which is the Y. Let me see. Yes, Y following a n-dimensional normal. So when we working on some transformation of our original random variable, and we want to use this normal to facilitate our analysis. Yeah. So U is defined in a way of Q1 minus A multiplied by Q2, and then V is defined is equal to Q2. Okay, so now, since we are interested in the joint distribution for U and V, and the only information about the distribution that we know is the vector of Y. So our first step is that we are going to express U and V in terms of Y. And then that could help us to introduce the normal distribution to our analysis of a vector for U and V. So what I mean is that we can write U and V in terms of matrix vector multiplication. So we can design a particular matrix that look like this, and then multiply by Q1 and Q2. So this is our Y that we know is following a n-dimensional normal. And this is what we design. We can call it as the matrix B. And then this is what we are interested in. Yeah. So now we recognize that a vector, this vector UV, is actually a linear transformation of another random vector that follow a normal. So we immediately can know that U and V is going to follow a normal distribution as well. So now the question is, what is the mean and the variance for U and V? Okay. So in other words, we are interested in B, expectation of B multiplied by Y, and the variance of B multiplied by Y. So here we should have B multiplied by the expectation of Y. This is just B multiplied by mu1, mu2. Do you guys want me to like write it down? I don't have the solution, but we can elaborate here. Maybe we can discuss or. So what I mean is that you need to multiply by the matrix B by mu1 and mu2 explicitly. Okay, so yeah, I'm going to do this from scratch, but just let me know if you see any typos. Yeah. So mu1 multiplied by identity minus A multiplied by mu2, and then we have mu2. Okay, so this is our mean vector for the U and V. Similarly, we have B variance of Y and B transpose. This should equal to, maybe I'll just speed up a little bit. That, and then we have the 2 by 2 block. 2, 1, 1, 2, sigma 2, 2. And here we have the transpose. So our diagonal elements stay the same, changed position for the off-diagonal elements. And then we just need to multiply the things. So a 2 by 2 multiplied by 2 by 2, we should end up with a 2 by 2. So let's work on B multiplied by sigma. So sigma 1, 1 multiplied by identity minus A multiplied by sigma 2, 1. So I think something that is common in the question regarding this term. So later we will simplify from using the information from the question. Okay, and sigma 2, 1 multiplied by the identity. Sigma 1, 2 minus A multiplied by sigma 2, 2, and then sigma 2, 2. Further multiply by that. Let me know if there's any typo. It's very likely there might be some typo. Sigma 1 1 minus a sigma 2 1 minus a sigma 2 1 minus a sigma 2 2. Okay, and then sigma 1 2 minus a multiplied by sigma 2 2, and then sigma 2 2. Okay, so just back to the question. This should equal to sigma 1 2 and equal to sigma 2 1. So the whole thing becomes a 0. Same thing here. So it is going to be a block matrix here. And let's see. I think, did I miss something here? There's one thing regarding transpose. So I think you probably need a transpose here. Okay, so just to make it more rigorous, because I don't have the solution, I'm doing from scratch. So make sure that you have matching the operation here, because it's not explicitly specified here. So this is going to be a symmetric or not. So just to be more rigorous, when you take the transpose, you might want to introduce a transpose here, because we don't know the dimension here. It might not be a square matrix. That could also happen, and that could also not be a symmetric matrix. So to take care of that, maybe you want to introduce a transpose operation here. And then also, this is going to be a right multiply. Yes, but for the details, you need to analyze the matrix A here. So here I'm just going to set it up like that for now, but it could also make things a little bit complicated. Depends on what does the A look like. Okay. So I think you will need to put a transpose there, because the question did not specify any additional information there. Okay, so we have the block in terms of the off diagonal. They are all already zeros. Okay, so now we just need to analyze the diagonal elements. So sigma 1 1 minus a multiplied by sigma 2 1, and then minus sigma 1 2 and a transpose. Okay, so now this thing here is going to the transpose is going to matter for up to this point. So when you perform some simplification, you need to pay attention to some of the details there. Yeah, so these are zeros, and then sigma 2 2. Question? Yeah.
In the off diagonal of the
Yes.
previous step, if we say convert sigma 2 1 to sigma 2 2,
Sorry, which one? Which elements? Which entry?
the off diagonal.
Off diagonal here. Mm-hmm.
Yeah, if we convert sigma 2 1 to sigma 2 2 and factor out sigma 2 2, wouldn't it be sigma 2 2 times identity minus A?
You need to say that again. Sorry. From where? Just starting from here.
Yeah, the elements where you're crossing them out to 0.
Yes.
If we convert sigma 2, 1 to sigma 2, never mind. I see from the instructions, a sigma 2, 2 equals sigma 1, 2.
Yes, so I think there's also a transpose here if you want to be more rigorous. Okay, so just make it more precise. So here, let's draw a line from the second, after the second entry here. So if we consider this, the first 4 elements as sigma 1, 1, so and this as sigma 1, 2, and this is sigma 2, 1. So you can immediately see that sigma 1, 2 is the transpose of sigma 2, 1. So here you will need to introduce a transpose, which is this one here. So the 1, 2 entry, the 1, 2 block is the transpose of the 2, 1 block. So that's the transpose. So I think this will give a very good example. So this 6 elements here, in terms of a 2 by 3 matrix, is the transpose of this 3 by 2 matrix. So you need a transpose there. And then this sigma 1, 1 transpose is just sigma 1, 1. And then sigma 2, 2 transpose is sigma 2, 2. So you don't need a transpose there. But here you will need a transpose. And then I think the A, you should also need a transpose here. And then these cancel out to 0. Yeah. Also, let's write down. Yes, so for matrix multiplication, you just need to make sure that, don't forget sometimes the inverse or the transpose, those are very, that will really mess up with your solution sometimes. So, okay. So in the question it's given that A sigma 2, 2 is equal to sigma 1, 2. Okay, and this is equal to sigma 2, 1 transpose. So let's see if anything else we can simplify here. 1, 2 here is, okay, yeah, so I think, yeah, this would help. So we should have sigma 1, 1 here minus A multiplied by sigma 2, 1. And here, we are going to write this as sigma. So I'm going to take another transpose here to have so this is essentially another copy of A multiplied by sigma 2, 1. So this thing here. And then A multiplied by sigma 2, 2 is sigma 2, 1 transpose, A transpose. And this thing is just, I might mess up a transpose somewhere, very likely. And also this is a plus. Okay. Yeah, maybe I'll just leave it for you to double check. So in the end, you should have sigma 1, 1 minus 1 copy of A sigma 2, 1, 0, 0, sigma 2, 2. Yeah, but this result is going to, so after you're taking care of the transpose. So yeah, I think here the transpose matters. So make sure you double check on the transpose, and then the things should cancel out and ends up with this. Although I don't have a solution, but I think it should be like that. Yeah. Any question or comments? Since we have only 3 minutes left, so maybe we take a look here. A sigma 2, 2 is sigma 1, 2. That's given in the question. And sigma 1, 2 is sigma 2, 1 transpose. Okay, and sigma 2, 2, that's Okay. So I think this should work. So if you write this as sigma A multiplied by sigma 2, 2 is equal to 1, 2. And this thing again is just sigma A multiplied by sigma 2, 1. Yep. So I think that should be correct. Yeah. And then you should have, so minus 2 copy of A multiplied by sigma 2, 1 here. So you minus 2 copy of that and then plus 1 copy of that. So you should end up with minus 1 copy of that. And that should be your solution. Yeah. And then for this one, you just need to plug in the formula and then also apply this particular substitution into your formula. And then that should end up with this particular mean and the variance matrix. Yeah. But this one is just plug in the formula first, and then using this to further simplify some of the terms. And then that should be in this form. Yeah. Okay, I think I'll just stop here.